Let's start with some very basics. If I have some base to some exponent, it equals a number. For example, 10 squared equals 100. Good? All right. If I rewrite this in a different format, I would write the top part, the variable looking thing, as the log base b of some number equals an exponent. Or in other words, the log base 10 of 100 equals 2. Example number 1. It says the log base 2 of 8. Now, if you look at your calculator, which is a super powerful tool, just like me, you'll notice that there is no log base 2 on there. So you're screwed.
Yay.
You're weird. So I'm looking for the answer. I'm looking for, oh wait, if we go back up and look, and we're talking about logarithms, it's taking a while to flip up here, isn't it? And I see a log thing, I'm looking for the exponent. So really what this is talking about is the log is really an exponent, as we learned a little bit earlier. Thanks to Liam. And oh, I know that logs and exponentials can be written back and forth if I change the format. So really what I could tell you is 2 to the e equals 8. And I went from log form to exponential form. Or in other words, the blue back to the red from up above in our notes. What does the e have to be for that to be true, Joe?
3.
3. 2 cubed is 8. So I know the e is 3. And so sometimes it's to our advantage to go back and forth between log form and exponential form so that we can solve an equation. Ooh, letter C. Let's go to letter C. In letter C, I know that this log has to equal an exponent, which means that 3 to some exponent, if I rewrite it in the Ben format, B-E-N, has to be 81. Or in other words, 3 to some power is 81. The answer is 4. Now, the reason, I mean, like a lot of people can see that or do that, but the reason that that's happening is really this 3 to the e is the same as 81, which is 3 times 3 times 3 times 3, or in other words, 3 to the 4th power. So if I see that the bases are the same, that must also mean that my exponents have to be equal. That's why you can answer 4. So if your bases are the same, then your exponents have to be the same if there's an equal sign in between them. Otherwise, it doesn't make any sense. Look at the one in the middle. If I look at the one in the middle, and we set this equal to an exponent, that means 2 to some exponent equals 0.25. This is not so easy to see. It's not like saying 2 cubed is 8. But you may recall that you can also write 0.25 as a fraction, otherwise known as 1/4. And if I rewrite that just a little bit more, really this is like saying 2 to some exponent is equal to 1 over, and 4 can be written as 2 squared. Now, it sure would be nice if there wasn't a fraction, huh?
Mm-hmm.
And what you might not recall, but I'm here to tell you and remind you, is that whenever you move something on the bottom of a fraction to the top, or vice versa, the sign of the exponent changes. So 1 over 2 squared is really the same as saying 2 to the negative 2 power. And so then my answer is that my exponent has to be equal to negative 2. So if you went to your calculator and you typed in, and I'll show you later how to actually do this on your calculator because there's a technique you can use, log of 0.25 base 2, you would find out it is indeed negative 2. Okay, letter D. In letter D, if we set that equal to our exponent, that means that 10 to some exponent equals 100. Not so hard there. We know that the exponent has to be 2 because it's 10 squared. In letter E, if we have that equal to some exponent, that means that 10 to some exponent equals negative 1. I'll give you a second to think about that. Not possible, or no solution. Because you can't log negative numbers or 0. You cannot take the logarithm, no matter what the base is, of negative numbers, or even a 0. Or in other words, anything that's less than or equal to 0 is not going to work out. So that's true here as well. Whenever you get a negative number that you're logging, or a 0, it's not going to work. Important to know. Put a star by that. These rules about logs. You notice how they use the A for the base? We used a B for the base. I don't really know why they use an A. Whatever. An example of number 1's rule is saying something like the log base 10 of 1 equals 0. Why? Because 10 to the 0 equals 1. That's the first rule. And we talked about how log and exponentials can be rewritten as each other, and our inverses, they undo each other. So here's an example of what rule number 1 is saying with numbers. Rule number 2. And I'm just looking at the letters, putting numbers in. So A, log, base, doesn't matter, pick a number.
15.
7, good, thank you. I don't think anybody said 7. Of 7 of 7 equals 1. That's what it's saying. If these two things are the same, the answer is 1. Why? Because 7 to the first power is 7. Notice how on the left I'm writing down logs, on the right I'm writing down exponentials. Number 3, the log base 13 of 13 to the second power equals 2. And 13 to the power of log base 13 of 2 equals 2. So again, all I'm doing is I'm just rewriting what they have using numbers. And the last rule is if the log, pick a number, 8 of 5 is on the left, it will be equal to the log of, oh look, it's the same thing, of whatever, 5, only if 5 equals 5. Or in other words, duh. Like really? You had to say that? So these are the numbers, or some numbers, that you could put in just to kind of see what it's saying. Now, one of the things I want you to notice is that since logs and exponentials are inverses, look up front really quick and check this out. Here's a logarithm with a base. Log and base. Log. Here's an exponential with a base. Logs and exponentials are inverses, right? They undo each other.
Yes.
See it?
Yeah.
Logs are exponents. The exponent. Do you see it? Okay. Exponential, number to a power, logarithm are inverses, same basis. See them? They undo each other. So if I see this or this, where the bases are the same, one's an exponential, one's a log, they undo each other, and you can already see the answer. Okay, in example 2a, log base 5 of x equals log base 5 of 8. Okay, if you don't get that one, there's not much I'm going to be able to do for you. That's not a joke. The x is 8. I mean, everything else is the same, so the last things have to be the same.
They're gonna be real.
Yeah. No. No complications. Next one. If I rewrite this, 5 to some exponent equals 1.
Zero.
X has to be 0, because anything to the 0 power is 1. That's it. What I want to show you in the next part is we've talked about in our class how we can transform things. Logarithms are no different. Doesn't matter if it's square, square root, absolute value, whatever. So we're just going to graph these things. So I'm going to graph the log graph first. So let's just say I'm going to graph this one in red.